Welcome to this second video on second derivative and concavity. We'll be jumping into question number 8 with our graph. We want to choose a value x where f prime of x is greater than 0 and f double prime of x is less than 0. So let's think about what these two statements mean. A first derivative that is greater than 0 means we are increasing. And a second derivative that is less than 0 means that we are concave down. So we can write that on our page. Now, I want to consider a point on this graph that has both of those qualities, concave down and increasing. One point that we see that can have both of those qualities is this point at x is equal to -1. X is equal to -1 is both increasing and is in a concave down section of our graph. So x equals 1, or -1, will be correct for one of those examples. Again, we just want to pick out one example that works for both of those qualities. Taking a look at question H, we want to choose a value x where f prime of x is less than 0 and f double prime is less than 0. So this would mean that we are a decreasing function. We're decreasing and concave down. So we want both of those two things to be true. Well, let's take a look at where we are concave down and decreasing. That would be on the other side of this portion of our function. An example there might be +1. We are decreasing in our slope and we are concave down in our shape. So x is equal to 1 would be a great example of that point. The last one in part I, we want to choose a value x where f prime of x is greater than 0 and f double prime of x is equal or greater than 0 as well. So this would say we are increasing and concave up. Increasing and concave up. So I want to go out and choose a single point that would qualify for both of those characteristics. So if I look in my concave up regions, there's really a couple points I could choose. One that kind of stands out is maybe at x equals 4. We are concave up and we are an increasing portion of the function. That's just one example. X is equal to 4. This one, you could pick another region as well. You could call x equals -2. This would be also a concave up region of our graph and an increasing portion of our graph. So both of those two qualities would be met at x equals -2 as well. So that concludes our discussion here on this problem with the second derivative and concavity.